Hi, welcome to this session of Connect Online. My name is Peter Riali. I'm a senior solutions engineer here at Couchbase. Have been in the data, IT, data processing, analytics business for 36 years now, both as a vendor and as an IT professional. And I'm looking forward to speaking with you. I'm grateful to you for spending your time with me in this session. Name of this session is Couchbase Analytics, Why, Which, How. The agenda is pretty straightforward. We're going to talk about why, which, and how. We'll talk a little bit also about resources and under the hood analytics. We talk about why. Anything in our business always starts with data. Now, the data that we will be using in this example will be some voter registration data from the state of California. It will be in JSON format. As you know, data in Couchbase is typically stored in JSON. Certainly will be if you're going to be using it for querying and analytics. Here's an example, voter doc. By the way, this is not a real person's data. The distribution of the data, the parties, the cities, the states, the counties, that stuff is real. I made up the names and the registration part. Standard JSON type document. At the upper level, we've got city name, address. We've got a document type that indicates that this is a voter document. And then we have an embedded array. The array indicates whether or not someone is registered. If they are registered in a particular year, how did they vote? Did they vote in person? Did they vote absentee? Or did they not vote at all? And for instance, here in 2020, this voter has not yet voted, so there is no voted element within the array. So now that we understand what our data is, let's talk a little bit about which type of access method we should use to get at the data. Couchbase platform provides, as you know, many different ones. So let's talk a little bit about query types. Key value access. Key value access is the most efficient way for you to get data out of Couchbase. You're typically talking response times in microseconds, certainly single-digit milliseconds. It's going to be called from your app in all likelihood or from your SDK. You must know the document key, or it makes sense, right? It's a key value. If you don't know the key, you can't get the value. And we have a great little utility that we can use that allows you to road test and benchmark what you're doing when you're working with key value. I'll show that to you now. Here's our little cluster. We've got about 19 million registered voters here in the state of California. You've seen the document type. It includes information on the voter and the voting habits. So let's go out and look at statistics. We'll see that right now, nothing is happening on this cluster, right? We're going to rectify that right away. We're going to go in, we're going to log on to our app server. And we're going to start what's called CBC Pillow Fight. This is Couchbase's load generator. And you'll see it takes almost no time for us to get, 800,000, sometimes 900,000 operations per second, even on this little tiny 3 data node cluster. So there's a lot of power associated with key value access, both on the read and on the write side. If we look at our stats, we see it jump up immediately there, almost to 1 million. So let's take a look real quick and see what our actual timing is on this stuff. And we'll see our big bump and cluster of operations are somewhere around 380, 390 microseconds. So for the most part, well under half a millisecond, most of our transactions are taking place. We get a few outliers here that go all the way up to, a millisecond or two. But for the most part, this is where all our action is. So that's, basic key value type stuff. Now, what if we are going to talk about we don't know the key and we need to have another method of accessing the data? For that, we use NCL, query access. Now, NCL is, as you may know, Couchbase's superset of ANSI 92 SQL. So it's a standard SQL language that has been evolved and has the linguistic elements that allow it to talk directly to JSON. You can write these SQL queries against your JSON data. You can get response times that are going to come back few milliseconds, maybe 10, 20 milliseconds, typically single or double digit millisecond return time. You don't need to know the document key because you're going to set up a secondary index on the fields that you might want to query. Now, you will use this typically for well-defined programmatic or application queries. Idea here is I've got a program and I've got lots of users and I need to have 100,000 queries per second or 10,000 queries per second or whatever your requirement is. You're going to set up an index and you're going to get exactly what you need. And Couchbase also has a utility, it's called CBC Nickelback, that allows you to test that. So let's take a look at what we mean by indexing and querying. If I were to go and look, say, at my indexing system here, first of all, let's look at an index. So my index is built on my voters bucket, and it's indexing these two fields, name and city. So if I provide a name and a city, I'm going to be able to retrieve data back very quickly. We'll do that here in the query pane. Pop in our query, and you'll see, 2.4 milliseconds I can retrieve for an individual voter and the city that, in this case, he is in, what it came from. Now I can also prepare these queries and execute with positional parameters. And I will show you this, because what we're going to do now when we want to use our benchmarking tool, CBC Nickelback, is we're actually going to send it 100,000 of these execute statements for the prepared query just to see what our results look like. In order to do that, let's just jump into our terminal. Right, and I'm going to paste in all right, so I've loaded up my 100,000 queries and I start to see it just sending them over there repeatedly so that we can get some kind of feel for what the load is on the cluster. If I actually go and look down at my query stats, I should see, okay, I've got 12,500 requests per second, getting a feeling for what my request time is coming back in milliseconds. And I also have a little bit of a early warning system here in the console that says, if I ever see anything, if I see any outliers, network lags or something that would cause a query to come back in over 250 milliseconds or over 500 milliseconds. And I'm seeing zeros on those, so I'm pretty happy about that. So let's go take a look then and see what our actual timings are. And if we look for our cluster, we can see it comes right about 1 millisecond, between 1 and these. This is still microsecond measurement here, so you'll see a bunch of different changes. These are all 1 millisecond, some in 2 millisecond, a few of them 3 or 4, but essentially single-digit millisecond retrieval. So that's good. That gives us exactly what we want out of query access. We also have full text search query access. Now I'm listing kind of the possibilities here for what your typical application will have. It will have key value access, maybe some query access, and maybe you got a little search bar in there or something, right? And the search bar is used for your loosey-goosey search queries. You do have to build an index. The good news is that index can be built right in Couchbase. So you don't have to send it off to a third-party search with all of the latency and things that are associated with that. You can also combine these search queries with nickel queries for hybrid kind of access, which can be very useful to you as well. I won't spend a lot of time showing you the search stuff because it's pretty straightforward. You've all seen searches before, but I've got a little search index on addresses. And if I go searching on Danny Holt's address, 9316 Bailey, not only do I get Danny's record coming back because I found a match there, but because it's search and it's supposed to be a little bit looser than standard query must match type access, I'm going to get some other 9316s. I'm going to get this voter who lives on 9316 Brianna Forge. So yeah, match the 9316 part. So that's search access. So those are your, as we said, your standard application access tools that you need to have, and you probably will have in your application. But we've got other types of access as well. And that's when we start talking about real-time ad hoc query and analysis needs. You don't always know what the Goonie guys in the analytics division are going to do, right? You don't know what they're going to ask. You certainly can't pre-cook queries and indexes for every possible thing they might ask, but you do know that they want these people to have this stuff in real time. So how do people do this? The traditional method and the how of what's been done in the past has been, I will go out and have my business app, which writes and reads data directly from my operational data store. That operational data store then is used to feed via some kind of a batch analytical database, a data warehouse or something. And then there might be another, further batch for whatever tool your analytics tool is using in order to do its work. And you might get some reads from the business app directly to the analytical tool, maybe not. The problem with this diagram, and in addition to the complexity of it, the additional systems that you have to support, the latency that's introduced, all of it kind of falls under the category of I got to put some ETL into my system here. I don't really want to do that if I can avoid it. And the way we avoid that in Couchbase is we call this no ETL for NoSQL, right? I've got a business app, I've got an analytical tool, my business app reads and writes operational data from the data service, and the database manages the rest. The database automatically shadows a full set or a subset of the data on the analytics service via DCP, which is Couchbase's data change protocol. This is the same thing that's used to replicate data and to create indexes and everything else. So it's very powerful, immediate, real-time replication and shadow of the data. That data is then available for real-time application access for analytics, or from your analytics tool to access it. Everything is simple, no unusual stuff to do. So how do we actually put something like this into practice? We're going to do that right now. So let's go ahead and go to our analytics console. And the first thing we're going to do is we're going to create a data set. So I've created a data set on my voters bucket for all the documents of document type voter. And I'm going to take and do a connect link local. What this says is start shadowing the data. Start taking every single document that is in the data service and get it into my analytics service. Now you can see it's kind of, you see the little numbers dropping here. It's going to go through and do that process in bulk once, after which it's going to be done mutation by mutation. Whenever there's a change on the data service, that's going to be immediately reflected on the analytics service. So you have truly real-time analytics without the danger of somebody trying to do queries directly against your operational data service. So you've got isolation and you've got power. So we've done that now. I don't have to do anything else in order to start doing analytic queries. So let's try one here. We'll just go ahead and do a quick count of registered voters grouped by party in the state of California. Data comes back by definition in JSON. We also provide a table view of it to make it nice and easy to read. And the beauty of this is, I can get this response, send it directly to my application and do whatever I need to do from there, or I can just have people read it from the console or from a Tableau or from another BI tool as well. Now let's do a little bit more fun stuff now that we've gone out there. I can wrap this existing query structure into a common table expression. And I will show you what I mean by that. Okay, here's my original query, which was that select party and count of voters group by party. I'm wrapping that up in a with and saying, okay, I want you to, whenever I refer to registered by party, it's going to be the stuff that comes out of here. This is called a common table expression, as you probably know. The beauty of this, number one, is that it makes your code a lot more readable and easy to maintain. Number two, it allows for reuse within the queries themselves. As your queries get more and more complicated, you don't have rerunning subqueries and things like that. It's managed directly by the common table expression. So I've got two here. I've got a common table expression here based on our original query, and a second common table expression, which was basically summarizing from the first. Then I'm taking the two of those in a select statement and coming back and just getting a percentage of registered voters by party in descending order. And you can see here, California is a one-party state. And almost 50% of the voting populace is Democrat, with no party preference, and Republican running a very distant second, even combined, a pretty close to a distant second. Now, I can improve this and get a little bit more granular here by going down to the city level. And again, I'm going to use a common table expression here. This time I've added a count by city, grouped by city, and then I'm selecting from that. Once I've done that, I can go out and for any individual city in the state of California, I can see how many registered voters I have for each of the parties. Now, the scenario that we're dealing with here, our analytical scenario, is that we are political consultants and we want to find a way to help people figure out how to make their media buys here as we're getting close to the election. So they want to know not only how many voters of each party in each city, but they want to know the top party in each city so that they know where they can go and focus their efforts. So let's go ahead and make a quick change to our statement here. And instead of just doing a straight order by city, we're going to add a window function. Now, the beauty of this is, instead of having to write multiple select statements to do this, I can just say, run this rank function over a partition data set, partition it by city, and only give me the rank which is equal to 1, meaning I want to have only the top party in each of my cities. Okay? And I've ordered that by registered, so I'm going to see at the top of my list the city that has the most of any individual. So Los Angeles has over 1 million Democrats, San Diego 352,000, et cetera, et cetera, et cetera. So I'm starting to get somewhere now where I'm doing things for my client. Now, the next question that the client's going to have for me is, well, gee, I don't just want these people that were registered at some point. I want to know the ones that are actually regular voters, the people that show up all the time. And as you recall, that information was embedded in that little array, which had the years and whether they voted in person or absentee. So we can go ahead and increase that just by dropping this into our. So you see what I'm doing here is I'm going out and saying, all right, go into that array and only give me places where that voted value, whether it's absentee or in person, I don't mind in this case, but it has to exist. The people that were registered but didn't vote, those don't help me. And then I'm selecting it down to the last 4 presidential elections because that's the election that's coming up next, and that's the ones where I really want to tailor that. If we run that now, I'm going to be able to go out and retrieve data back that's going to give me the result that I'm after. And then we're going to make one more little selection to it and then call it a day, right? But we're already getting pretty close. They know where to focus their efforts. And the next kind of revision that I'm going to make on this is somebody says, well, gee, I don't need to go after all these Democrat cities because that's what the state typically is. I want to recruit some of the other guys and see if I can get them to vote for me. So I'm going to replace that with a similar query. I've added a third common table expression, which was based on my original query there. And I'll say select from that, and it'll only give me the ones where the party is not equal to Democrat. And that's where I'm going to go out and I'm going to spend my money for my radio buys. And you'll see that I can come back with, in again, approximately 10, 11 seconds, I've got my targets to go after, pretty small subset. And, you know, going from, what have I been talking here, 15 minutes to you guys? Soup to nuts, operational data system to completed analytical application based on my client's needs. It's pretty good. So you want to get going with this stuff, I'm sure. What are your resources and what should you be looking to in order to learn this stuff, in order to become better at it, in order to start really working with it? Well, first of all, you're here on Connect Online. There are some great sessions and some really good people that are going to be presenting on these. Mike Carey is a professor at UC Irvine. He's kind of the academic father of a lot of the underlying technology associated with Couchbase Analytics. He's definitely worth listening to. I would go see his session. Idris is the principal product manager for the analytics product. He's in charge of everything associated with analytics and super sharp guy. So you're going to want to hear that one. Till is the senior director of engineering, and analytics is his job to implement. So he's involved in a couple of these as well. He's really good at explaining the underlying technology associated with it. And then finally, in the last session there, that big data analysis section, that's got Dimitri. Here in Couchbase, we refer to Dimitri as the human query optimizer. So Dimitri's well worth listening to as well. Once Connect Online is over, I've got some other resources for you. There's an interactive tutorial that allows you to start from the very beginning and learn SQL++ or Nickel for Analytics. They're the same thing. And it takes you from very simple hello world type thing in lesson number 1 all the way through pretty complicated query examples. So those are good. And then the Couchbase blog. I put in several examples here and I'll paste them into the chat window when this is presented. But you can always just go to the Couchbase blog and select analytics. There are choices there, or you can put in a search with the word analytics. There are a lot of really solid articles about analytics on there by people who are very close to the product and that do this stuff for a living. So would highly recommend doing that as well. That is the end of kind of the tutorial part of this and the hands-on part of this. And if you take these last 2 screens and walk away, I won't be unhappy with you. If, however, you want to stick around and talk a little bit about what's under the hood, that's the next conversation that we're going to have. And what I'm going to kind of take you through is what's the process that Couchbase goes through when it runs a query. Okay, a query typically starts when an application submits the query over the REST API. Now, all of the nodes listen for query requests, and any single one of them can grab it and take care of it. So once that is done, the second step is to parse, analyze, optimize, and create a query plan. This query plan is done by a single node, which will kind of act in the capacity of managing the metadata and the associated queries. It's not a single point of failure because any node can act like that. It just, in practice, we will only have one do it at any given time because we do want that node to not only know the requirements for the individual job that it's optimizing, but for all of the existing requirements for the other jobs that are also running. Next step, once that is created, is that I'm going to go out and send that query to all of the nodes. So every single query node now will work in parallel, and each node will have detailed instructions on what each partition will do. Now, what are partitions? A partition is a function of the number of cores, CPU cores, and the number of disks that you have available. And if you have more, you get more partitions, which means more massively paralleled work. And this is important. We're going to talk about this more a little bit. The job's worked on in parallel on all partitions, and then that result set is sent back by each partition to the individual nodes, which may have to do repartitioning and reaggregation, in which case it leverages those same available partitions that were available before to go out and create those. It's essentially TEB space on each of those. Finally, that data is going to be consolidated by the calling node. There may be a final sort and merge or an aggregation, and that's then finally going to be sent back and returned to the application. Now, the reason I'm showing you all of this is because I want you to understand that you can improve and scale your analytics results linearly just by adding more nodes to your cluster. And you can fully expect and predict what those are going to be. You do want to prepare the individual node that you're going to be adding in order to fully leverage the disks. Couchbase on a single disk node will automatically assign the correct number of partitions. If, however, you have a disk that has multiple disks, for instance, I'm running one that has 2 disks in NVMEs for the instance type that I'm running, I want to go in and I want to assign those paths by hand, and I'm going to show you how to do that. So let's pull this up. And we're going to SSH onto our analytics node. Now, this is a spare node. Hasn't yet been added to the cluster. Right now, let me just show you. Right now, I've got 3 analytics nodes. Okay, 1, 2, 3 of them. I'm going to show you how I could go and add a 4th, prep and add a 4th. So in order to do that, first of all, let's look and see what we have. And you'll see I've got a couple of different drives available to me, NVMe drives. So I want to make sure that I access each of those disks. Now here's the process that I'm going to go through to do that. I'm going to go ahead and make sure that I create on each of these nodes, each of these disks. I've got 16 processors, so I'm going to create 8 nodes on each disk, 8 paths on each disk, each of which can be used as its own separate partition. I also want to make sure that Couchbase is the owner of these, which is why I'm doing this chown command, or chown command, your choice. So there you go. There's my new disks, and let's do the same thing for the other drive. All right, so now on both of my drives, I have 8 new available paths for me to go out and channel my data to. The way that I actually initialize that node to leverage and be aware of what those things are is a process called, not surprisingly, node init. So here's my node init command, and I'm going out and saying, all right, create a new analytics path for each of these disks. And you'll see if I got to go pick up my library book. You'll see that if I run against with each of my 16 processors, each of them will have his own disk path to work with. That's highly optimized behavior. So we'll run that. He'll come back and tell me success. That's been initialized. And we're done there. So let's go add this node to our cluster. This is analytics, my fourth analytics node. And you'll see if I bring him up, he doesn't yet have a cluster. So he's going to have to join one. So we're going to join an existing cluster. The cluster I'm going to join is this guy over here. I could pick any one of these, but I'll just copy the one I already have here in my editor. We're going to join that cluster. We're going to have to give it credentials. The services that we're going to run are going to be analytics only. And if I look and see my analytics DITS paths, these are the 16 paths that we created using that node init. The node's got those as part of its boot up now. Theoretically, I could go in and I could individually add these by hand, but I think we all know that's an accident waiting to happen. So that's not what we're going to do. We're going to join now. All right, I've joined that guy. And if I go over here, I'll see I've got a node here that didn't exist before. So let's rebalance him in. Now this rebalance process is going to take, I don't know, 60 seconds, maybe a little less. And the reason that it takes this amount of time is I've gone from existing 48 different paths. I had 16 disk paths or partitions on each of 3 analytics drives. I'm now going to be adding a fourth. Hey, 30 seconds, nice, 24 seconds. So now I've gone and added that. I've got 64 paths. So I should expect that I can get my results back from this same query that I was running before in about 3/4 of the amount of time. Let's go ahead and close him. And let's run it again. It took me 11 seconds before. Drum roll, please. And we're coming back in 8 and change, which is good. So you can see you can determine what your needs are for your analytic queries, scaling it up to what you need. If you decide that you love your analytics query so much that you want to put it as part of your application and that 100,000 people are going to run it every second, guess what? You're going to write a separate index and you're going to make this part of your nickel query system. Great thing is you already know the data's there because this data is a shadow of it over on the analytics side. So that's a quick kind of look at underneath the hood. Last thing I have to say then, once I get my deck to participate, is thank you. I appreciate you spending the time with me. I hope that you learned something. I hope that you'll go and attend some of the other analytics sessions, and very much look forward to working with you again.